Solving equations require factoring or combining like terms, and there are two types of questions. You could solve for all of the values of x, or alternatively, you could solve for x's that are on a certain domain. So let's take a look at the first ones, and the first question is straightforward. The question is, what are all x's such that the cosine of x is equal to -1? I'm going to remember the graph of the cosine starts at 1 and goes down. And the question here is, what is this value? And that's what my x is going to be. Now, that's just going to equal pi. So x is equal to pi. It's half of the 2 pi. You could also go to your unit circle and determine that your x is equal to pi. That's all that requires. This one, you have to factor out a sine x to get it into a product. Once you have it in a product, then you can set both of those factors equal to 0 and solve, because this can equal 0 or that can equal 0. So now you have two cases. Sine x can equal 0, or sine squared x minus 4 equals 0, which means sine squared x equals 4. Sine x would equal plus or minus square root of 4. Now, this is equal to 2. The sine x can never be greater than 1 or -1 because the graph looks like this, and the top is 1, the bottom is -1. Can't have 2. Therefore, what you're going to do is just cross this off because those are Arrhenius solutions. Back here, sine x equals 0. It occurs at this point and this point, and therefore your answer is going to be x equals 0 or pi. Also, looking at this one, I can factor out a cosine x, sine x minus 3, apply zero product property, and notice that this can never occur. When is the cosine x equal to 0? It's going to equal 0 at this point right here, which is at 0. Now, these answers for the first three would be under the condition if x was between, x is going to be defined between and including 0 and 2 pi. However, it can also be for all values of x. Now, if it's all values of x, that's going to change your answers. So when you look at the first one, that answer is going to be pi plus, when does that occur again? It's going to occur every 2 pi units, 2 pi k, and k really is all integers. Now, you don't have to write this down, the second part, because it's implied. So this would be your answer. Similarly, on this one, you would have 0, pi, and then it would continue every pi units here, where the sine x is equal to 0. So your answer that you can write here is going to be x equals 0 plus pi k, or simpler fashion would be just pi k. On this one, cosine is equal to x equals 0, so your x is equal to 0. That's going to happen every 2 pi. So for the general solution, it's going to be 2 pi k. All right, so I did specific answers, and I also did general answers. The general ones are in green. I'd like to do just one more problem. Let's take a look at number 8, and this will be a specific one. So I'll go back and do that in purple so it's consistent. And you're basically going to solve for cosine x because there's only one variable. And so you end up getting radical 3 over 2. Now, when you have this situation, you have to remember that the cosine x is equal to a positive number in certain quadrants. So again, Santa Claus, this will tell me that it's positive in the first and the fourth quadrant. Now, if I think about reference angles, my reference angle is going to equal pi over 6 because the cosine of pi over 6 equals radical 3 over 2. I looked on the table. And now what I can do is determine what those angles are in the first and the fourth quadrant. So my x equals pi over 6, but it's also going to equal 11 pi over 6 as it goes all the way around. So that would be your answer between 0, including 0, and not including 2 pi. So really be careful on the directions. Check if it's a specific case. You'll always have it to be defined. So that would be purple. And if it's a general case, it would say all values of x's, which would be green.